Okay, so today we're going to talk about how to build pie charts using the HTML5 canvas. On the canvas, you can see here, this is my example. This is what we're building right here. I have some data. I have an array with 5 values inside of it. Each one has a label, so I've called it name, and then a number, which I've said is troops. These pie-shaped segments here represent the percentage of the total of all these. So if you take all of these numbers and you add them together, that total number, I'm saying 90,000 is so many percent of the total. So this is the second biggest. This one is the biggest. You can see Lannister is the biggest number, Troop, and the Targaryen is the second largest one. So they are the second and first largest pie segments. Okay, so let's take a look at this. We have on the HTML, there's just one element. It's the canvas tag. That's the thing with the border right here, which I've got centered on the page, stretched out, max width 100%. I've got a function for generating a random color. So all the colors that I'm putting inside of here, just a simple one line of code. You want to generate a random hex code. You need the hash mark in front of it. I'm generating a random number, so this will give me something between 0 and 1. It'll be a long decimal, like up to 15 decimal places, I think it is. So this will be my random number. I'm converting that into a string, but I'm converting it into a base 16 string. So I'm going to get this big long number, which starts with 0 and then a decimal, and then a whole bunch of hexadecimal characters. What I'm saying is start at position 2. So after the decimal, go up to position 8. So I'm grabbing 6 characters from that string and then sticking them on after the hashtag here. So that's what this does. This gives me a random hex value. Okay, DOM content loaded. When my page loads, I get the canvas. That's the thing with the IDC. If we look up here, there it is, the IDC. I grab that. I get the context. I'm drawing in 2D. So that's what we need to do, is get the context 2D. And this is the variable that I'll be using for most of what we're doing here, drawing these lines and shapes and text. I'm setting a width and height just so I've got it set and I know exactly how big it is or how many pixels there's going to be in my canvas. Then I'm going to get the total of all these numbers. So I'm using the array reduce method. I'm just looping through and I'm adding them all together. That's all we're doing here. I have another video on the array reduce method if you don't know how that works. But we're starting with 0 and then we're just summing the numbers as we loop through them. So we have a total now. My starting angle, when you're drawing arcs, when you're drawing pie segments, this is what you're doing. You are having a starting angle and an ending angle, and you're drawing an arc. You need to know what the radius is, you need to know what the center of the circle is, and then you need to know the angles. Now the angles are measured in radians, not in degrees. If you haven't worked with radians before, it's just another way of measuring the angle in a triangle or the angle in a circle. So if I was to start right here, let's say this is 0, and as I go around the circle and I get all the way around to the opposite side right here, if you're measuring in degrees, that's 180 degrees. If you're measuring in radians, it's 3.14 radians. So it's pi radians. If you go all the way around the circle back to your starting point, that's 360 degrees or 2 pi radians. So we're measuring this in radians. If I took 2 pi, which is the entire way around the circle, and I multiply that by the percentage, that is going to give me how big this segment is. That's going to give me my ending angle. So inside here, I've got my start angle is 0. Radius I've set to 100. CX and CY, these are my circle X and Y, the center X and Y, this point right here. I'm just taking the middle of the canvas, taking the width and height, dividing it by 2, gives me the midpoint here. We loop through our data array for each object inside here. So house is going to represent each one of these. So each one of these objects in turn is going to be called house inside my for each loop. I get my random color, my line width, so this is the thickness of these lines is 1 pixel. Stroke style, it's a dark charcoal gray. And then begin path. This creates a new layer on the canvas for me to draw. I'm going to log out that information that I'm writing out here. I don't need this, but it's there if you want it. My ending angle. Okay, this is the thing I was talking about before. I take the number of troops divided by the total. That gives me my percentage. I multiply that by 2 pi radians. So math.pi times 2 times whatever this percentage is. That will give me how many radians it is. I add to that my starting angle, so I know it's going to be this big, but to know where on the circle to end, I have to add it to this start. And that's what we have here, adding the start angle, which began at 0 for the first one. Okay, so we move to the center of the circle. We've picked up our pen, we've set it down in the middle of the circle. Then we call the arc command, which says, what's the center of your circle? What's your radius? Where's the starting angle? Where's the ending angle? And this Boolean at the end says, do you want to go clockwise or counterclockwise? We're going clockwise. But with false, which is the default, we're going clockwise. When I get to the end of the arc, I'm drawing a line to go back to the center point right here. Then I'm calling fill and stroke, which will actually put the color and these strokes in there. Okay. Close the path, that finishes the layer, so that is the pi segment itself. The other part that we're doing here is going to be the label. Now, just before I get to the label, I want to talk about drawing the second one and how we're working with start angle and end angle. Start angle, we set to 0. Then we added the value of it to here to get the end angle. For the next one, I need to start at this point. This has to become my new starting angle because I'm going to add it to the end. Otherwise, they're all going to get stacked up right here, one on top of the other. We don't want that. So down at the very bottom of the loop, the very last thing we do is we say the start angle is now going to be whatever we calculated as the end angle. So now I can start here and draw to this point, and then we're resetting the start angle, draw the next one, reset the start angle, draw this one, and so on. Okay, the labels. I did another begin path, close path. Pardon me. You can omit this. If I was to comment out this close path, this begin path, and this close path, and save it, this is still going to work. It's just this is a good practice to get into. When you are creating your shapes, give them their own layer. It makes it easier for manage. It makes it easier for you to avoid mistakes and times where, oh, that style property that I was using, that color or that line width or something, as you're changing these properties, you don't necessarily want them to carry on to the next layer. You don't want to be drawing a shape and then all of a sudden have it draw another line to connect to some other shape on the canvas. So make sure to encapsulate all the things that you're doing inside of a begin path and close path. All right, for the labels, pretty simple. I'm doing a line center on them. I'm giving them a font. I'm giving them a size. I'm giving them a color. Now, the mathematical part of this, let's look at the Lannister one, for example. What I want to do is I want to write this outside the circle. So if I take the radius, which is 100 pixels, and then I multiply that by 1.5, basically I get to 150 pixels. I get to this point out here. On that point, I'm going to center the text right here. And I'm going to take the midpoint for each one of these. So this comes out to here. This one, if we took the midpoint and came out, there it is. Again, here comes out to this, and for this one, comes out to right here. So we're drawing an imaginary line from here out to this point. So 1.5 times the radius. Remember that. We're going to pick the midpoint between these two angles. That's where we want to draw this line, the imaginary line. So I take the start angle, the end angle divided by 2. I take the average of the two. That's my midpoint. Then I have to figure out what is the x and y coordinate of this point. If I was to draw a line out to here, what is this coordinate? Well, I need to use a little bit of trigonometry to figure this out. Let's look at this Mormont one. Okay, if we took a look at this pi segment right here, if I was to draw a line straight down from this point, let's zoom in a little bit. Oops, on this side. Oh, yes, my CSS I've got set to max width 100%. Let's get rid of that. There we go. That's easier to see. Now, this pi segment, if we were to draw a line straight down here so that we had a 90-degree angle right here, so perpendicular line going up, I'm creating a triangle here, a right angle triangle. And that's what trigonometry works with, is right angle triangles. If we were to imagine that the length of the hypotenuse was 1, so this is 1, we can calculate the length of this line and the length of this up to this point by using sine and cosine. If you remember your high school math, if you've done trigonometry, then we're using this, so, ka, toa. And that basically means that the sine of some angle is equal to the opposite over the adjacent. The cosine of an angle is equal to the adjacent, oh, sorry, my mistake there. And this is the adjacent over the hypotenuse. Now we're talking the lengths of these lines. So if you took this angle right here, which we've calculated, we know what the angle is from here to here. So when we find that midpoint, that's the line that we're going to look at right here. We're drawing this midpoint line, and we're saying from here, come straight down. Okay, from this to this, that's our hypotenuse, and we're saying that that's 1 unit long. Great, that's 1 unit. Now, this right here, this is the opposite, and this is the adjacent. If we're measuring this angle that's right inside of here, so the sine of that angle is equal to the opposite side's length divided by the hypotenuse. Well, if we're saying the hypotenuse is always 1, it's the same as saying that the sine of the angle is equal to the length of the opposite side divided by 1. And for this one, it's the adjacent side divided by 1, because we're always saying the hypotenuse is 1. Okay, now, coming down here like this, this opposite, this value is sine of whatever that angle is. Well, the angle was the average between. It's the midpoint. The start and the starting and the ending angle divided by 2 added together. That gives me the average right here. So this angle, that's my angle. So if I do sine on that angle, it's going to tell me how big the opposite side is. If I do cosine on that angle, it's going to tell me how big the adjacent side is, so the bottom side. Now, if we're doing all this with the assumption that the hypotenuse is 1 pixel long, or 1 inch, or 1 centimeter, 1 unit long. We're measuring things in pixels, so I can say, this is going to be 1 pixel, this is going to be 1 pixel. So these are going to be a fraction of a pixel. But if you multiply it out times 100, that 1 pixel times 100, the hypotenuse scales up here. And the length of the opposite scales up by 100. And the length of the adjacent scales up by 100. They all scale up by 100 pixels. So whatever you're multiplying the hypotenuse by, you multiply the others by that as well. So here it is. The sine of theta, which is our angle right here, times 1.5. We want to go out to here. This is the 150 pixel mark. So it's 1.5 times the radius times that. Math cosine times 1.5 times the radius. So there is our delta y and delta x. Basically, how far did you move in the x direction and how far did you move in the y direction away from this center point. Boom, there it is. Right there, that is our starting point. So when we write the text, that delta x and delta y, we just have to add the center point of the circle to that. We don't want to necessarily, there we go, we don't want to be writing these things up here, measured away from this corner. Like, I don't want to write it up here. I want to take this and move it over here. So it's this point plus the delta y and delta x. And that's what gives us the values spaced out around this. And that's it. That's how you build a pie chart with Canvas. So a little bit of a trigonometry lesson, whole bunch of stuff about Canvas. Hope that helps you out. I will leave this whole thing as a code gist so you can download it and play with the code and experiment with all the different things. You can set your own colors. Try putting your own colors into the data right here, and then instead of generating a random one, use the ones from your data. All right. As always, thanks for watching.